So in general, whenever we want to write an acid reaction or a base reaction, we take that acid and we throw it into water. And so when we take this acid and throw it into water, it'll form H pluses and A minuses. I say H plus, but H3O plus and H plus are essentially the same thing. It's just an H plus on this water molecule. If it's a strong acid, this will 100%, there'll be none of these HAs and they'll only have H3O pluses and A minuses. If it's a weak acid, what we're going to have is we're going to have a bunch of HA and very little H pluses and or H3O plus and A minuses. So let's come over here and take a look at our possible choices. And when we do, we're going to see that, let's look one example after another. So this one right here, we have a bunch of HAs. Okay, that's good. But we have no H3O pluses and no A minuses. So that didn't dissociate at all. Here we have H3O pluses, but no A minuses. Here we have, you might look at this and go, wait, we have H pluses and A minuses, but in reality what we should have is we should have H3O pluses and A minuses instead of just H plus and A minus. And by the way, there are no HAs here at all. So remember, we have to have some HAs if we have a weak acid. Here we have HAs, we have, again, A minuses, but then these right here are not attached onto the H2Os. So this is not actually what's happening in water. In this case right here, we have H3O pluses and A minuses, but we have no HAs. This would probably be an example of a strong acid. Here we have HAs, right? And then we have some H3O and A minuses. So we have HAs and H3O pluses and A minuses. So that indicates to me that could probably be that's probably our correct answer, our weak acid. Here we have only H3O pluses, that can't be. And here we have HAs only and no A minuses. So our correct answer in this case has to be this right here. Now let's look at our bases over here. So typically with the base, we throw it into water and it grabs a hydrogen off of the water and it forms an HB plus and an OH minus. Remember, cations typically are acids, anions are typically bases. But when we're looking at the difference between a weak acid and a weak base and a strong base, strong bases are always going to have OH minuses. Now that doesn't mean that all strong bases have OH minuses. In fact, if you look back at one of my solubility videos, we say one strong cal-bar. So group 1, strontium, calcium, and barium with OH, those are the only ones that are strong bases. Everything else, if I had a magnesium with hydroxide, that would be a weak base and it would not fully dissociate. But in this case, we're looking for a weak base, and so we're either looking for an end result of HB pluses and OH minuses and still some of the B's left over, or we're looking at a BOH, right? But we're having some BOHs and some B pluses and OH minuses. So let's take a look here. In this first scenario here, we have a bunch of H2Os and we have B pluses, but we have no OH minuses. So that can't be it. Here we have some B pluses and OH minuses, but we have no BOHs here. So, and if we take a look back at this diagram right here, what we would expect is we should have some HBs, some OH minuses, and some B pluses, but we do not. So this can't be a weak base. Here we have BOH, right? So we have a couple of BOHs, and then we have some B pluses and some OH minuses here. So this actually looks like a hydroxide that is not fully dissociated. So we have this right here is likely going to be our weak base, because if we take a look at this right here, if all of these BOHs become B plus and OH minus, then it is a strong base. But if only some of the BOHs become B plus and OH minus, that's a weak base. And over here we have still some BOHs, but we also have some B pluses and OH minuses. So this is likely going to be our weak base. Then we take a look at this one right here. Here we have HB and we have HA and A minus. That's kind of an acid. Here we have no B pluses at all. Here we have a bunch of BOHs, but we have no B pluses and OH minuses. Here we have, well, no B pluses, so nothing's dissociating here. And here we have some BOHs. So if we go back here, the only option we really have is this guy. Let me find it here. Did I run through it already? Maybe it was 4, maybe it was 3. This is the correct answer. So here we have some BOHs, which are these guys over here. they did dissociate to form B pluses and OH minuses, but not that many. So this is ultimately, you probably have to do a few of these to get the hang of it, but hopefully this has been helpful.